Hello friends, we are back again in the machine learning algorithms, and today we'll be doing a very simple explanation of what is logistic regression in machine learning. And this is me, alright, and let's start. So what we understand with logistic regression that it solves the problem of classification data, which is having discrete values. So the classification is like whether a wine is red or white, or whether a given flower falls in which category of species. So we have the classification, all right, whether an image is of a cat or a dog. So therein logistic regression falls. Okay, this is a multi-label classification, and this is binary classification. Two classes involved, and here three classes are involved. Now, this is the regression, but this is solving problem of classification. Please do not get confused. This is called regression because it uses linear, or you can say the line equation of linear regression. So linear regression solves the regression problem, and this regression deals with continuous data, for example weather prediction or determining the age of players, or house prices. So they both have the same underlying line equation, and so they are called regression. Okay, so now let's understand further. So now, from this image we understand that this is logistic regression, and here what it does, it models the probability of a certain class. So how it does it, that when it converts log odds to probability, it uses a logit function, which is a logistic function. Okay, so this logistic function, this models, it uses this function to model a binary dependent variable. Okay, and this assumes an S or sigmoid or logistic function. So this logistic function converts these log odds to the probabilities, and this assumes a sigmoid function. Now let's understand this further. It will be very clear. Now suppose I have this threshold value as this point, and this is 0.5. Any value which is lying above 0.5 will be classified into one class, and which is falling below this will be classified in a different class. And when a linear line equation fits this, this will be assuming a sigmoid shape or an S shape. Okay, and this is logistic regression. So what is the mathematical or equation behind this? How does it really comes to this thing, this this shape? So this is the formula behind it, which helps us to get the shape, and it does it by log of y upon y minus y, 1 minus y, and this y is the log odd which we want, the class which we want to classify. Okay, and beta 0 plus beta 1 x1 plus beta 2 x2 up to the n classes. Now suppose I have taken this example of iris dataset, and this b1 would be the first attribute, b2 would be the second attribute, b3 third, and b4 the fourth attribute, since we've got 4 columns. So first one can be sepal length, second will be sepal width, petal length, and petal width. So by filling these, with different data set values, you get various equations, and when these various equations are being converted into probability and a threshold value is being fixed by the model, if certain value falls above it, it will be classified as versicolor. If certain values fall below this, few classes would be versica setosa, and between something, then you can get virginic. So what are the advantages of logistic regression? So this is easy to implement and to train the data. This is used with categorical data, and it is easy to use. Your variance is also low, and variance is the spread of the data around the mean, and this is low. And this is use of feature extraction. The features are good for your data, and then can improve your efficiency. And we see that logistic regression sometimes give very good efficiency. An example is the heart disease data set, which I have done it. Please go through it once. I'll provide it in the end of the description or in the description box link. So let's see this logistic model, and they can be updated easily with the new data using stochastic gradient descent. Now this is some new term, stochastic gradient descent, but it is quite important in machine learning, which I'll come up with a new video for this term explaining what it is. And this provides great efficiency, and this is a widely used algorithm. Now with advantages, there are certain disadvantages also. And what are these? So this can predict on categorical outcome. And what it does it, this is vulnerable to overfitting. And when a model overfits, this underperforms, efficiency lowers. And this is suitable for linear data. And what happens is this make assumptions. Logistic, linear, both many models they make assumptions. And when you're making assumptions, that means that you are biased. That means that the model is biased, and this will not give me a generalized data. This will lower the efficiency of my model. So what I do is that it makes assumption that all the data is in numeric form. And so what you have to do is you have to convert the data into a suitable form before training the model. So sometimes the data like age, we don't want to convert it into that log form, but it is converted because that is how we will be able to fit it into the model. But it will not make sense. We'll explore it in our data set. And let's just come to the next video, which will be upcoming, is then which logically concludes this video that now if you have got a categorical data, how would you make it suitable for logistic regression? So the next video will be dealing about how to convert your categorical data into numeric format so that the algorithm can be trained on that data and they could be fitted, and the various techniques used at one-hand encoding, label encoding, and cat boost with their challenges and strengths. Okay, so stay tuned and thanks for watching.